This is the blueprint for my castle generating tool. It's done in the construction script, so you'll be able to see it in the viewport while you're editing. The first thing it does is it adds a wall mesh to the spline point and adds that to an array. And then it checks if there are pillars. If there are pillars, then it adds the tower mesh to an array. Once again, same if there's roofs, tower roofs. If there are no pillars, or just for each number of spline points, it will get the whole array of the wall pieces, set the transform, apply materials, and connect the spline if the spline is closed. This is repeated for the towers and the tower roofs and the gates. Just a very similar process. This is mainly done using a lot of functions, as you can see from the left hand side. One of my personal aims in this project was making it very function heavy, because I started off with the project, I started off doing it without functions, and decided there's lots of little pieces that needed to be put together, and it was very difficult to find the things that I needed when they were all in the same place. So I decided to put some time aside and create some functions and put everything in the functions, which helped me significantly with my time management, because it allowed me to find errors much easier and fix them a lot quicker than I would have been able to if everything was just in the same place. But yeah, generally it for each component, so the wall, the tower, and the tower roofs, it will find the scale of them, also find the location, set them, and then apply a material on top. I also have in the editor the material is public, so this can be changed with any fileable material that is in the world space. The meshes are also public, so you can change the mesh types as long as they abide by the rule of they need to be 100 Unreal units by 100 Unreal units, and then any shape used will scale correctly. Yeah, I'll just show some of the main functions that get this to work. One of the main ones is setting the wall transform. How this is done is it gets the rotation, which is a custom function, and puts it into a world transform. The rest is it just gets it returns a location of the spline point, and sets it. Same with rotations of X and Y. The only difference in them is the width. So the Y transform, the Y scale, and the Z scale are different. They depend on the public variables of width and height, which can be changed to customize the experience you want. The getX scale is also a pure function. I'll show off now. So how this works is it basically takes a spline point and takes the next one, and gets the distance between them, divides it by 100, because that is the scale of the size of the mesh. So it will then scale it for each unit in Unreal, which is the same as the spline. So the mesh will always go from one spline point to another. This part at the bottom is this. It does the same thing, but this is just for if it's connected this happens when for the last spline point, because before it gets the current spline point in the index and adds 1, but because the spline is connected, it would have to get the current one and take away 1 from the spline point to get the first one. Yeah, and then that will determine the scale of the wall piece, the length to make it so that it gets from one spline point to the other exactly. Next, I'll show off the get rotation, which was the pure function. This is very similar in the way that it starts off by getting the length between them, the length between the two spline points. But then what it does is it gets the y value, checks if it's greater than or less than 0, just so that you're scaling it, rotating it in the right way, because if you didn't check that, it would always like mirror from one side to the other. It would always stay on one side, it wouldn't go the direction you want. What is done, so once you have got the length between each vectors, each point, it normalizes the vector, and then checks it, does the dot product against just the normalized vector in the x direction. So basically checks it's always checks against the x direction, and then you do acos in degrees, and what this does is it basically gets the steering angle between the spline point and the x-axis, which determines the rotation of the wall piece. So it'll always be in the right rotation. I ended up having a lot of errors with this because I did not normalize it. I was just doing the length, the distance between the spline points, and checking it between just a really high number on the x value, which if the distance between the two spline points exceeded that, it would do things that were not intended. And I could have fixed that by just increasing the x value once again to an even larger number. But to make it more concise and correct, I decided to normalize it. So no matter the distance between the spline points, this will always get the correct rotation between them. And then this part down here is the exact same thing. It's just done for the final spline point, as mentioned earlier, because this checks between the current spline point and +1, whereas this bottom one will check between the current spline point and minus the first one and the last one, because yeah. So that's it for the rotation. The other things aren't really that important. Well, they are, but it's a lot simpler to show off. For the spline transform, it just gets the location, the transform at the spline point, and then adds a static mesh there. That's the same for every single mesh part. For the materials, once again, it just gets the material instance, which is public. Sorry, it gets the material input, which is public, and sets the material instance, the mesh instance, as that material. Yeah, I think that's about it. Everything just has custom inputs, so that the functions work. They can be used multiple times. So for the apply materials, I didn't need to apply materials for the wall, apply materials for the pillars. I could just use the same function for every single mesh because it takes the same inputs. Yeah, that's it.